I am Joshua Maloney, and this is my presentation for HOR 102, Entomology and Plant Disease at Cape Cod Community College. My IPM plan is based upon the Gypsy Moth. First, a little bit about IPM. After synthetic organic insecticides were developed during World War II, their use in the United States proved problematic as troubles associated with their use became very evident. Pet resistance, target pest resurgence, secondary pest outbreaks, and contamination of the environment led to the creation of IPM. Many past practices were very harmful to the environment. Most of us know about DDT, but before that we used arsenic-based poison. Also, see in this photo, a prior method was to light everything on fire. This project will give a description with a history of the gypsy moth, a monitoring plan based on an entomologist trying to protect the students of Cape Cod Community College. The monitoring plan will have listed thresholds. I will then have a treatment plan and a monitoring plan to evaluate that treatment. In the late 1800s, Dr. E. Leopold Trouveau introduced the gypsy moth. So what is a gypsy moth and why is it here? On the left we can see a photo of the male gypsy moth. On the right is Dr. E. Leopold Trouveau. He intentionally brought the moth species to his home in Medford, Mass. From France. He was interested in getting silk production in the less temperate Massachusetts climate. Some moths accidentally escaped, and they have since remained a threat to the forest in the northeastern United States. A big problem with Trouveau's plan is that gypsy moth caterpillars do not make silken webs or tents. So what's the problem with gypsy moths? On Cape Cod Community College, the big problem is student medical reasons. The caterpillars, and to some extent the moths, have hairs that cause allergic reactions. This allergic reaction is often referred to as the moth itch. Another reason we may need to intervene is to prevent defoliation of trees on campus, particularly white oak, which are already on decline. My integrated pest management scenario is based on Cape Cod in the summer of 2022. It is based on the hypothetical that droughts in the spring and summer of this and next year allowed for the gypsy moth populations to explode on Cape Cod. So now to the description of the pest. Gypsy moths have one generation per year, and they have 4 distinct life stages: egg, larvae, which is the caterpillar, pupae, and adult moth. Female gypsy moths are known for cryptically laying eggs, which often results in them being transported by cars long distances. Female gypsy moths are incapable of flight, so egg masses are usually laid close to where they pupate. The eggs hatch, and the larvae that emerge are the caterpillars. They can disperse large areas being blown in the wind, even though they're flightless. This is the stage where the gypsy moth consumes the foliage. They often grow from 1/16 of an inch to over 2.5 inches long. Around the 3rd week of June in Massachusetts, the caterpillars will find a safe and protected location to pupate. Pupating is when the caterpillars metamorph into their adult selves. Lastly, we have the adult moths. The female on the left can be seen laying egg masses. Note how they don't look silky whatsoever. And on the right, we can see the male gypsy moth with its feathery antenna. So now to our monitoring plan. The need for pest intervention at the college begins with student medical reasons. Dermatitis from gypsy moth hairs produces rashes similar to poison ivy and can also affect respiration. In addition to the medical reasons, are to prevent defoliation of trees in and around campus. Gypsy moth caterpillars' favorite host is white oak, which the Cape Cod Community College and surrounding conservation land is full of. This scenario assumes that the trees are already drought stressed. Trees like this really can't maintain their vigor. It was the dry seasons that led to the reduction in natural enemies. The fungal pathogen Entomology interrupted a 100-year cycle of defoliation. Like most parasitic fungi, they require water to be active and successfully invade caterpillars. In this scenario, it has been very arid in the spring and summer. This monitoring plan is for the 2023 season. It assumes that no active or preventative measures have been taken. Here is the 2017 and 2018 State Defoliation Survey map showing the damage that gypsy moths had done. A monitoring method will be trapping to gauge population size. On the right is an antique gypsy moth with a female in a cage in the middle. The males would be attracted to the female's scent and get stuck on the wood adjacent the female. All of this information for the monitoring plan goes into estimating size. On campus, pheromone traps will be used to monitor current populations for potential rises. Estimating gypsy moth density begins by summing the total number of egg masses in an area. That is expressed as a number of egg masses per acre. Egg mass size can also be interpreted to provide some information about the condition of the gypsy moth population. Small egg masses are indicative of a declining population, whereas large egg masses are indicative of an increasing population. The three primary objectives I have are nuisance abatement, prevention of defoliation, and prevention of tree mortality. Each of these has its own threshold. According to the United States Department of Agriculture, intervention is generally appropriate in residential and forested areas when the threshold value of egg masses surpasses 250 per acre. This often isn't justified in Massachusetts, seeing as the gypsy moth is a staple to our forest. The next two categories are to prevent defoliation and prevent overall tree mortality. The photo on the right is Trouveau's Medford home, and it shows defoliation in the first couple of years the moth was introduced. According to the United States Department of Agriculture, tree growth loss begins at 40% defoliation. Additional damage is proportional to percent that defoliated. Trees begin to refoliate when about 60% of their foliage is lost. Here are the United States Department of Agricultural numerical thresholds for treating gypsy moth. So now on to the treatment plan. The federal plan slowing the spread. National program launched in 1999. Eradication of the gypsy moth in Massachusetts is not a plan of any IPM plan that I know of. Eradication as a goal is only useful for outbreaks in small isolated populations of the gypsy moth. In the treatment plan, this uses integrated approaches. Cultural, mechanical, and biological treatments are looked at. This ensures the least impact on our environment and the most reward for our cost. This plan does not use any traditional chemical pesticides. As you can see on the right, arsenic as a poison used to be very common. Many of us know the problems with DDT and that we relied on chemicals too heavily and that they persisted in the environment. And at the end of the day, these chemicals didn't even work. Barrier zones have been repeatedly set up and lost to these hungry caterpillars. The first control type is to keep our forests on Cape Cod healthy. I know that this sounds kind of grandiose, but I think that we should be taking care of our forests. There are not many mechanical controls for the gypsy moth, but one that we can do is to destroy egg masses. As you can see in the photo on the right, this has historically been an option. Initially, this was the only option. Workers will destroy all egg masses in and around campus by scraping them into a can of soapy water. Seeing as every egg mass can contain from 100 to 1,000 eggs, this adds up. Traps have absolutely no effect at all. Hundreds of thousands of adult male moths can be caught, and that will have no impact on the population of males that have already mated before the capture. Another mechanical control is tree banding. This technique kills and captures older larvae when they migrate down the tree during day to seek shelter. This tactic does not significantly reduce the population, but it will be used on campus to reduce the number of caterpillars with allergy-producing hairs. Here is a map of Cape Cod Community College in the surrounding area. All deciduous trees on and around campus will be banded. Nationally, biological tactics are the primary treatment for gypsy moth. The bacterium Bacillus thuringiensis, commonly known as BT, Seen on the right, lighting egg masses on fire was initially a very serious option. More specifically, the biological pesticide Bacillus thuringiensis KURSTAKI, or BTK, will be our biological option for reducing the caterpillars. We will apply on and around campus, directly to the leaves soon after the caterpillars emerge. We expect it will be April or early May. Another option that we will not be taking advantage of is mating disruption. Mating disruption uses a naturally occurring insect pheromone called disparture, which is synthesized from female gypsy moths. It works tremendously well, and it confuses male gypsy moths and disrupts mating. The problem with it is that it is introduced to the environment in PVC flakes. The flakes contain 17% disparture and 82% polyvinyl chloride. PVC is toxic and it is going to persist in the environment. That's why we will not be using it in my IPM plan. No offense to disparture. Horticultural oils are an option. They've been available for decades, and the majority of the products are highly refined petroleum-based oils. They work by suffocating the eggs. Once the sprayed oil dries, it is entirely effective as a pesticide. This will be used on college campus in the evening hours for egg masses that cannot be scraped off. Nucleopoliohedrovirus, or GEPCHEC, is a viral common cause for the collapse of gypsy moth population. It is a naturally occurring virus and was one of the first viral pesticides to be registered with the EPA. It is specific only to gypsy moths, so it is used primarily in sensitive habitats. Therefore, we do not have access to this. The last biological control is the use of insects, mammals, and other birds that naturally feed on gypsy moths. We will be obtaining certain ants, ground beetles, and parasitic wasps that will attack gypsy moths at different stages. The tiny non-stinging wasps, Uencratus cuvanae, deposit their eggs into gypsy moth egg masses. When the wasp larvae develop, they consume the gypsy moth egg, killing it. These wasps are non-native, so this could cause another problem. But what could go wrong? Like the last step of any good IPM plan is a post-treatment monitoring plan. This is going to be a continuance of the monitoring plan into the next year. We will continue to rely on state aerial defoliation surveys and baited traps. It is incredibly difficult to estimate the natural interactions that occur between gypsy moths and their enemies. So in conclusion, we can thank our artist and amateur entomologist, Dr. Trouveau, as the gypsy moth is now a Massachusetts native. As it was introduced so close to us, and its range is only expanding, the gypsy moth is not going away in Massachusetts. They currently occupy less than 1/3 of the suitable forest region in the continental United States that could support a gypsy moth outbreak. Ongoing threats are not only caused by gypsy moths. Many new outbreaks occur when humans unknowingly move them on cars, moved goods, or lawn furniture. Thanks for watching my video. I hope you learned something about the gypsy moth.